Now let's have a look at example 18. It says here that the graph shown on the right is the position x versus the time t of a particle traveling horizontally according to the function blah, where x is the horizontal distance in meters traveling to the right of the particle's starting point, and t is the time in seconds since the particle started moving. So we have a first look at the graph to see what it's talking about. So roughly, initially, the graph is about at 5-ish, so the particle starts at 0.5, then at around time 1, the particle is at a position of roughly 6.5, so then it starts at 5, then travels to about 6.5 position, and then it turns around to the left, and then travels around the 4 mark at time 3, and then turns around and then travels to the right again, increasing in displacement. So if we visualize this on a number line, we see that at time 0, the particle starts at 5 as the starting position, and then about 1 second later it heads to about 6.5 meters, and then it turns around so that by the time another 2 more seconds has passed from time 1 to time 3, the particle has reached roughly a position of about 4. So in that case, in our number line, the object then turns around so that it hits point number 4 at roughly 3 seconds. And then the object then turns around again to head towards the right, towards the positive position. So they'll swing around and then they'll keep moving towards the right as time increases. So that's essentially what's happening in this scenario. So what's part A asking for? Part A asks, in what direction did the particle move initially? So with this word problem, let's first define some variables. So let x equal horizontal distance traveled, and it's measured in meters. We're also going to take that moving left is negative and moving to the right is positive in this case. And then we also have t for time. And the question says it's measured in seconds. Now, we know our displacement function is given by t cubed over 2 minus 3t squared plus 4t plus 5. So in what direction did the particle move initially? Well, initially, where is it? So at t is 0. So when t equals 0, what is our x position value? So x of 0 is 0 cubed over 2 minus 3 times 0 squared plus 4 times 0 plus 5. So based on the graph, we can see that the object started at position 5 meters. And then as we can see from the graph, it heads towards 6 meters. So in other words, it's heading towards the right direction. So we can say that from the graph, the particle is initially traveling from 5 meters when time is 0, when at 0 seconds. And it's moving towards 6 meters because we can see from the graph it starts at 5 and then it moves towards the 6 mark. So in other words, therefore, the particle initially travels to the right of the observation point. The particle initially travels to the right. So that's interpreting going from 5 to 6 of the initial point, initial position. Next, let's have a look at B. B is asking for calculate the average velocity of the particle over the first 2 seconds. So average means a gradient, in other words, rise over run, or y2 minus y1 over x2 minus x1. So the fact that it says over the first 2 seconds tells us that x2 is 2 and x1 is 0, because that's a span of time we're looking at. So velocity is the rate of change of displacement. So we're looking at y1 and y2 being the 2 positions or the displacements of the object across the first 2 seconds. So average velocity is your gradient, aka y2 minus y1 over x2 minus x1. So I guess the difference is instantaneous rate of change or instantaneous velocity would be your derivative. In contrast to average is just the overall rate of change, which we'll calculate using our gradient formula, y2 minus y1 over x2 minus x1. So we need 2 points. So we know that when t equals 0, our displacement is 5. So in other words, we have the point 0, 5 to work with. And then we want to have it over 2 seconds. So when t equals 2, we need to work out what the displacement is of that particle. So let's sub it in. 2 cubed over 2 minus 3 times 2 squared plus 4 times 2 plus 5. If you put this in a calculator, you get 5. So in other words, we get the point 2, 5. So then this gives us x1, y1 and x2, y2 to work out the gradient or the average rate of change. So then we've got, therefore, average velocity equals 5. So that was y2. Y1 was also 5. So 5 minus 5 over 2 minus 0, which gives us 0 over 2, which is 0. So therefore, the average velocity over the first 2 seconds, is 0 meters per second. So don't forget your units, meters per second, because that's the units for velocity, speed. Now, just because the average velocity is 0 doesn't mean the object hasn't moved, right? So velocity, remember, is speed but with direction. So if you look at the picture, essentially what it's saying is if we started at 5 when time is 0, it's saying that it moved to the right to about a maximum of about 6.5, and then it turned around and moved back to that same position point of 5 at the time 2 seconds. So essentially the overall change in position is that it essentially feels like it hasn't moved, but when in reality it did move right a bit, and then it moved left a bit, it turned around and moved left a bit, but it ended up at the same position as where it started from. So it feels like that the average velocity across the 2 seconds it's as if it hasn't moved, when it actually has moved to the right, then turn around and moved the same distance to the left. So part C is asking for determine the speed and acceleration at which the particle is traveling after 3 seconds or at 3 seconds. So here we want the speed, the rate of change of displacement versus time. So we want the derivative, so dx dt. And once we find the speed, we can work out acceleration, because acceleration is the rate of change of speed or velocity over time. So we need to work out dv dt. So let's work out for part C. We want velocity, or v, of t is dx dt, or if you prefer the dash notation, you would write it as x dash of t. What was our displacement function? Our displacement function was t cubed on 2 minus 3t squared plus 4t plus 5. So if we had to differentiate the first term, it would become 3t squared. So take the power down, take away 1 from the power, and then keep the over 2 because that's the same coefficient. So we would get 3t squared on 2. Our next term, we've got minus 3t squared. So minus 3 times 2, that would give us minus 6. And we take away 1 from the power, so that would become 1. So we have minus 6t. Next, we have plus 4t. So if we differentiate a single t, we just left with the number in front, so that's plus 4. And lastly, the plus 5 would disappear because it's just a constant. There's no t involved. So we've got, plus 4. So that is our velocity function, so v of t. Now we want v of t at 3 seconds. So when t equals 3, v of 3, so put in a 3 wherever t occurs, So if you use a calculator, that gets us -0.5 or -0.5. So again, it's okay for the negative sign because the negative indicates the direction at which the particle is traveling. Then what do we want? We want to work out acceleration. So acceleration, or a of t, is the rate of change of velocity with respect to time. If you prefer the dash notation, you would write it as v dash of t. And again, we do it dt because our function's in terms of time, because it's the rate of change over the time at which the object is traveling. So we differentiated our velocity function, which was 3t squared over 2. So 3 on 2 would be our starting coefficient. So that'll be 3 on 2 times the power down times t to the new power. 2 minus 1 is 1. The minus 6t now becomes minus 6, and the 4 disappears because that's constant. The 2 and 2 cancel, so we're left with 3t minus 6. So we want what happens when t is 3. So a of 3 is 3 times 3 minus 6, so that's 9 minus 6, which is 3. So therefore, the particle is traveling at 0.5 meters per second left direction, in a left direction. So we're interpreting what the negative sign means, and is accelerating at 3 meters per second square at time of 3 seconds, at 3 seconds. So when you calculate displacement, velocity, or acceleration, make sure you interpret what the negative signs mean and the positive values, if there's any. So in this case, negative velocity means we're moving in a left direction because velocity is speed, which is 0.5 meters per second, with a direction left we took as negative. And the fact that our A, acceleration, is 3 means we're accelerating, we're increasing in speed. In contrast, if we had a negative 3, we would be decelerating at 3 meters per second. So we need to make sure we interpret the signage of our values.